Hello guys, welcome back to the Python course. Ganatra here, and in this video we will start with one of the really important topic in Python or in any programming language, that is object-oriented programming. Now, what is object-oriented programming? A programming language that is influenced by or that works according or a programming language in which everything is represented as a class and object is called as an object-oriented programming. Notion of an object-oriented programming or object-oriented programming in simple terms. Yes, this might not be the correct definition just for now, just for the understanding purpose. Let's just keep it like that. Now, if you might be thinking that since Python is an object-oriented programming, why we were not using that notion or that technique until now? Why the introduction of object-oriented programming at the moment? Because we have done the whole basic course and we never saw object-oriented programming there. And also we have come across a few videos in this advanced course, and again no object oriented programming there. Then why the introduction of object oriented programming now? Because I think now this is the correct time when I should introduce you to this topic, because we are almost ready to grab this concept, this advanced concept, because which we are ready with all the basics or all the stuffs that we required for object oriented programming. Until now we have worked on our Python skills, and I think the Python skills until now will be up to the mark. So it's now time, and until now what we were doing was or the notion that we were using is called as structural programming. So in programming there are different type of the notions that are generally followed, few such as structural programming, functional programming, object oriented programming, event driven programming, and there are few more, right? So until now what we were doing was called as structural programming, and the programming that we did in which we had few methods. Even the project that we developed was called as that notion was called as procedural programming, because we were playing with the methods here and there, and we were doing the calls in the methods. So that is called as procedural programming, and the simple if else and all these things are called as structural programming. So now let's start with the discussion on object oriented programming and what is object oriented programming. So since the day one, Python has been an object oriented programming language. Yes, now you might know or not know, or we might know or not know, or we have seen it or not seen it, but yes, since the day one, Python is object oriented programming language and we have worked with that. Now how? Go to the very first basic class and try to remember the example of the variable. Let's say I want to declare a variable x is equals to 5, and let's say I want to print it. It will print 5. We understand that by now, right? Now let me check the type of this variable, and for that we know that we have a type method. So let's write the code and see that what it will return us. So what it will return us is we are getting here class int. Okay, so with this we understand, yes, this variable is of int type, but our focus right now is not on the type method or that int. Our focus is on that something that is class. Now what is a class? So we will surely discuss that in the upcoming video, what is a class. But for now understand that it belongs to a class integer. That means the variable that you just now declared x belongs to the class integer, and that x is now the object of the class integer. Okay, right now it might seem a bit confusing, but it is not. It is really simple as we move ahead into the series. So why I am discussing this, or what my point was behind discussing this, to prove that yes, the Python is purely object oriented programming. The thing is that we were not using it in that way, but from this videos we will or from in this video or in the upcoming videos we will use this notion of the object oriented programming. So Python is an object oriented programming, as we saw this example as well. And I think now the concept of object oriented programming might be little clear. I won't say that it should be absolutely clear to you. If you are not getting anything what we discussed until now, it's okay, go slow, because this is a concept new to you and sometimes this might be confusing. But stick till the end of the series and you will surely understand what is object oriented programming and how it works. And if you have understood the object oriented programming, yeah, right now even I have not explained you object oriented programming, right? But only understand that object oriented programming is something in which we have classes and object, and everything is represented as classes and object. And similarly we have seen that in Python as well, everything is represented as classes and objects, and we verified that using that example as well. So before moving on further and writing some code in Python for the object-oriented programming, let us discuss few really important concepts of object-oriented programming or the properties of object-oriented programming. So object-oriented programming we have four really important properties. So the first one is abstraction, then we have encapsulation, inheritance, and polymorphism. So these four are the really important properties of object-oriented programming. So let's see them one by one. Let's have a discussion on this theory because this is necessary. First, once you understand all these things, then understanding the concepts internally with the code will be really easy. So and you won't get all these things, the discussion on all these things in Python course anywhere. But yes, just to make your learning experience great, I have added all these things. So let's discuss everything one by one. So let's start with abstraction. Okay, so abstraction is just a term. Now let's take a simple example and then let's understand what it is. So before moving on to the programmatical meaning or implement or understanding it with respect to programming, let's just take a very simple example. Now let's say you are driving a car. Okay, so what you will be concerned about is how to use a brake and how to use a steering wheel. For example, let's just consider just two things. Okay, so if you are driving a car and if you want to use a brake or a steering wheel, you will use it accordingly to your requirement. Okay, without bothering that how they are actually working or how they are actually made, right? So normally we wouldn't think about that how they are made or how they are actually working. So what we are discussing about right now is just abstract things from the whole environment that concerns you or that are required by you. Because as a consumer, I don't want to do anything by knowing that how does they actually work or how they internally look or how they are manufactured. As a customer, I just need to learn or understand that how they are, how to use them, and just take my keys, take my car, and go for a ride, right? So according to a customer, that's my level of abstraction, or that is abstraction for me. But let's say if I am a mechanic, then I will not be concerned about that how this is developed, that how this car is developed or what was done to develop this car, how was the design done, and all these things. As a mechanic, what will be about my concern is that whether the parts are working properly or not. If they are not working properly, I will fix them, and just I am done. I am not concerned about whether the user is using them properly or whether the user is using it, how it is using it, or how it is developed, designed, and all these things. So again, the level of abstraction for that mechanic is at his requirement or his level. So the level of abstractions differ for the different people. Similarly, in programming, what the abstraction means is just abstract the things from the environment, abstract the properties that are required by you for that application or for that thing, and just ignore all those things. So this is basically what is abstraction in object-oriented programming. Yes, if you read other blogs or if you surf on Google, you will find a hell lot of definitions and all these things, but those are just definitions. So if you want definition, you can see below. This is just the definition, but what the example that we took is something that you will be really able to correlate and understand. And yes, I might be wrong, but this is the best explanation that I could give you in the simple terms. So now let's move ahead and discuss what is the second property of object-oriented programming, that is encapsulation. Let's talk about encapsulation. Now what is encapsulation? So encapsulation is like putting all the things into a black box. Now what is this black box? So what I mean by putting everything into a black box is that we put everything into the black box. That is, we put the implementation part into the black box and we show the user whatever is necessary for the user, right? We hide the implementation part. So this is basically called as encapsulation. So let's move ahead and discuss more on it. So it might seem a bit similar to abstraction, but in abstraction, the levels of abstraction differs from user to user, or the let's say consumer and mechanic. That example that we took. So it differs from person to person, the level of abstractions, and in that the user is just bothered about their abstraction or the properties or the things that they need. But whereas in encapsulation, we show to the user only the things that we want them to see. Rest all the things we hide them. So we hide them into, and the concept is called as that we hide them into a kind of a black box. So this is called as encapsulation. So now let's take again a simple example on encapsulation. Let's say you go to a doctor and doctor gives you some medicine, and that medicine is in the powder form. Okay, So he gives you three different color powders, and he says that take the first one 3 milligrams, second one 2 milligrams, and the third one 50 milligrams, and mix them and then take 3 times a day. So does it make any sense? No, it doesn't, obviously, because as a patient you don't want to do all these things by taking the powder and doing all the measurements and then taking the medicines. So this doesn't make any sense. But what if the doctor takes a capsule, mixes all the powders that are required according to the measurements, and that gives you that capsule. So what the doctor did was what the doctor did is doctor hide all the implementation part, or all the things that are not necessary for a patient to see. For a patient only a capsule is enough, so that capsule might work as the black box that we have been discussing, and that powder is our implementation part. Thus the doctor can also stay happy with the patient, and patient is also happy with the cure that the doctor gave him. So this was again a very simple example on encapsulation. As we move ahead, you will understand that what is encapsulation, and one of the major example of encapsulation is classes. In classes we bind all the things like attributes, variables, methods, and all these things, and we show to the user only what the things are necessary. But when we write the code for the classes practically, you will be able to appreciate it more, and surely we will discuss at that time as well. Now let's move to the third property, inheritance. Now as the name suggests, inheritance, we are going to inherit something. Now let's take an example that we all agree that we inherit something from our parents, right? We inherit some of the other genes from our parents. That so this is similarly in programming. We inherit some properties or something that we don't have, and some other code already has it. So we inherit that things into our application or into our code. Thus this is called as inheritance, and this gives rise to a parent-child relationship. Since the properties that inherit will become a child, and from which we inherit will become the parent. Thus inheritance gives rise to the parent and child relationship, and also it supports or enhances one of the most important feature of programming, that is reusability. Because if you already have a code written already, then rather than writing that code again, we will simply inherit that code into our application. So this is really important, and we will have a really good discussion on inheritance in the upcoming videos. And the last one, that is polymorphism. Now what does polymorphism means? Let's break the terms. Poly means many, and morphism means forms. So polymorphism means many forms, that one thing can have multiple forms. So this is a very simple description of polymorphism. One thing can have many forms, and you will see that how our code or our application or our methods can have different forms according to the situations. So that's it for this video. That was regarding the object-oriented programming and the 4 really important properties of object-oriented programming. So from the next video we will dive deep into this and discuss more onto classes and object, and surely write some code. So that's it for this one, and see you guys in the next one.